Hi, everyone. Thank you for joining our session today on Lux. My name is Doris Lee, and I'm a PhD student at the RISE Lab. Thank you for joining this very last session today. And today we'll be learning a little bit more about Lux, which is a tool that helps users explore and discover meaningful insights from their data. And so as an overview of the roadmap ahead today, we'll first introduce the basics of Lux and its motivation, and then you'll see a demo of Lux in action. The later half of our session today, we'll move on to the hands-on portion where you'll get a chance to try out Lux on a couple exercises and a freeform playground to explore different data sets. We'll be using Docker for the hands-on portion of the talk. So if you haven't have Docker installed on your computers from the earlier session, I'd really encourage you to install it now since the installation is going to take a while. There will be a quick survey at the end before we conclude the session. And at any point today, if you have any questions, feel free to leave your questions on Slack and we'll address them throughout the session. So let's get started to learn a little bit more background about Lux. Data scientists often go through this multi-step process spanning from data collection and cleaning to modeling and deployment. We saw that in many of the tools at RISE Camp this year, which helps users in various parts of this data science lifecycle. Here, we're focusing on the data exploration part of the workflow and illustrate how this still remains a challenge for many working data scientists. Now, what is exploratory data analysis, or EDA for short? The well-known statistician John Tukey describes exploratory data analysis as an attitude and a willingness to look for patterns and trends in your data. In his book titled Exploratory Data Analysis, he draws the analogy between doing EDA and doing detective work, and he outlines the techniques for doing EDA, from manually browsing and inspecting the data to basic querying and computing statistics, as well as visualization of the data. So fast forward 50 years from Tukey, what does EDA look like in 2020? So computational notebooks like Jupyter have become the go-to tool for everything from data cleaning to visualization and machine learning. And notebooks have become increasingly popular for data scientists to iteratively experiment with data through their code. And on the other hand, we also have interactive visual analytics tools, including commercial BI tools like Power BI and Tableau. And these tools are highly accessible in bringing data insights to the analyst with the ease of point-and-click interactive interfaces. However, even with the advent of these incredibly powerful tools, there are still challenges that hinder the flow of data exploration when we go from a question in our heads to discovering actionable insights. In particular, we identify 3 resistors that are common to the data exploration process. The first resistor is that while programming tools are highly flexible and allow users to perform a diverse set of tasks, they're largely inaccessible to analysts without coding expertise. On the other hand, interactive tools are highly usable and effective for expressing visual intents. However, most of these systems are limited in terms of their flexibility in the tasks that they support and are very hard to customize. That means that there's a huge disconnect between these 2 classes of tools. And from a user's perspective, having to import and export to and from these 2 classes of tools presents a barrier to exploration. The second point of resistance comes from the high effort that is required to visualize data programmatically. Take, for instance, let's say that we are given a data set of cars and we want to plot a bar chart of average horsepower by origin. We first need to think about what the visualization should look like, what graphical encodings and mark we should choose, and how to process that data correctly. We then need to translate all of these specification details into code. Here we show 2 examples of just the amount of code that is necessary to generate a single visualization. And this is in 2 popular Python visualization libraries, matplotlib and plotly. So the substantial programming effort that is required for visualizations often hinders data exploration, especially when the users only have a vague idea of what they're looking for. And note that writing code to plot a single visualization is just one tiny point in this vast space of exploration, possible options for exploration. In particular, the analysts typically have to go through a tedious process of navigating through a large number of decisions in order to find relevant insights in their data. So even when they end up with what they're looking for, they can often miss out on important insights that are in their data sets. Another common problem is that the analyst might not know what sets of operation they should perform on their data to get to these desired insights. They can often lose track of where to search for these insights or get stuck in their analysis. So the three resistors that we discussed represents this gap between how people reason and think about their data and what actually needs to be done to these data to get to these insights. To address these pain points, we've developed a lightweight open source API called Lux. And the goal of Lux is to make it easier for data scientists to explore their data, even when the user doesn't have a clear idea of what they're looking for. So to bridge the gap between code and interactive interfaces, we are bringing the power of interactive visualizations directly into Jupyter Notebooks. To lower the cost of programming, Lux features a powerful intent language that allows users to specify their analysis interests. To help guide users to relevant analysis, Lux provides visualization recommendations of data frames automatically to users. So now let's take a quick look at a demo of what Lux can do. And note that you'll have a chance to work with these notebooks hand-on in the later part of the session.
This is a quick demo of Lux. We can see that in order to use Lux, all we have to do is add this line, import Lux. Here we look at a dataset containing information about colleges in the US, and we load in this dataset using the Panda syntax as is to read in the CSV file. We notice that when we print out this data frame, we see the default pandas table display. And we can also toggle to a set of recommendations that are generated by Lux. Lux recommends visualizations essentially for free to the users by helping them visualize their pandas data frames. Recommendations in Lux are organized by these tabs, which represents potential next steps that the users can take in their exploration. Lux displays three sets of recommendations to show an overview of the dataset. First, we have the correlation tab. This shows a set of pairwise relationship between quantitative attributes ranked by most correlated to least correlated. Then we have the distributions tab, which shows a set of univariate distributions ranked by most skewed to least skewed. We also have the occurrence tab, which shows a set of bar charts that can be generated from the dataset, and we showed the most uneven distributions to the most even distributions. Now we find that there is a highly correlated chart that is shown in the correlation tab, showing the relationship between SAT and ACT scores. This is not super interesting and even a little bit redundant since these two attributes represent almost the same information. So we decided that we want to drop the ACT column. Lux seamlessly integrates with pandas so that we can do our data transformation on the data frame directly and see the recommended visualizations based on this updated data frame. So here we can see that the recommendations are updated based on the column ACT being dropped. Given that we now have some overview visualizations, let's say that we want to find out more about a particular attribute. For example, we might be interested in the median earnings of students after they graduate. So we can set the intent here as median earnings, and this is an intent that is now attached to our data frame. This essentially specifies what the user is interested in. When you print out the data frame again, we can see that the recommendations are steered to what is relevant to the intent that we specified. So on the left-hand side here, what we can see is the current visualization corresponding to the attributes that we've selected. On the right-hand side, we have enhance, which shows what happens when we add an additional attribute to the current selection. We also have the filter tab, which adds an additional filter while fixing the selected variable x, y.
So in the demo, we saw how a fairly typical data analysis workflow where we're working with data frames in a Jupyter notebook can be completely transformed by just adding a single import statement. With Lux, working with data frames suddenly now means affording a lot more visual richness to encourage these meaningful data exploration. And we do this while preserving the same data frame semantics, meaning that all the nice functionalities that we get from pandas, like we've seen from importing CSVs to dropping columns, we can still do in Lux. And by printing out the data frame, Lux recommends visualizations essentially for free to the users And one of the things that we find is that while tables are an effective form of visualizations, Lux provides an alternative way that data frames can be visualized. Users can toggle back and forth between these two complementary views. And we find that while there are often tasks that are more amenable in the table view, like trying to get the structural and schema information about the data frame, in other scenarios, the recommended visualizations may be more useful to get a quick visual overview of your data. We were also able to quickly clean up our data by dropping a redundant column and update our recommendations directly. A key aspect of Lux is a flexible and expressive language for communicating your analysis intent to the system, and we saw how data frames can be attached with an intent, which enriches the data frame with signals about what visualizations we should display to the user and what are that are more relevant to their analysis interests. So to recap, in the first part of this talk, we've seen that there are 3 common types of resistors that hinder data exploration. We then demonstrated how Lux addresses some of these pain points by supporting visual discovery alongside the data frame workflow. Before we move on to the hands-on part of the session, I wanted to pause here and take any questions about what we've presented so far or what's coming ahead. So we'll I'm going to turn off the screen share and do a bit of a Q&A here if anyone has questions.
Hi, I have a question. This is a very powerful tool. And so you show that to print out the data frame in order to show the functionality of Lux. So in some case, the data set could be very huge. Then it's hard to like display the whole data set in the notebook. So in this case, how do you address this or to trigger the functionality of Lux? Is there any other way rather than printing out the whole data frame?
Yeah, that is a very good question. And scalability is something that we're actively kind of working on. So supporting Lux on large data sets. What we currently do is we do, if the data set is too large, we do some sort of sampling from Lux. And so what you'll be actually seeing is a summary of your data on a particular sample. Another thing that we're doing is for very expensive histograms that would be generated, we are binning the data so that we're sending less data forward to the front end. But this is an active area that we want to work on and support Lux on larger data sets and trying to allow people to get kind of a quick overview in a short kind of interactive time scale.
Thank you.
Thank you.
Question. This is Yuxiao from Futureway. I have 2 questions. First is that how do you deal with non-quantitative features can also be visualized? And the second question is about yesterday we have learned about modding, which can be also used in notebook. And I'm wondering, is there any interaction between this Lux and modding? Thank you.
Yeah. So to answer your first question about non-quantitative attributes, so currently Lux has an internal data type called a nominal data type. And what we're doing is we are plotting the bar charts of the nominal data type. So let's say I think we saw in the example that we had origin, which is cars from different countries, then we would actually plot a bar chart according to that and doing some aggregation based on the group by attribute, which is the categorical variable. To answer your second question about Modin, we have been actively talking to the folks in Modin. So this is, again, going off the same direction under the previous question is talking about scalability and thinking about whether some of these data frame operations could be scaled up. And so this is something that we also want to work on in the future.
Cool, thank you.
Yeah, I have a questions about in your current demo. It looks like that you are basically doing density plot for every variables as well as pair plot for correlations. Is that it or anything else? Yeah.
So what you've seen kind of is the overview. So in the overview screen, what we have is the univariate. So this is the density plot or the histogram that you you were mentioning. And then we have the correlation. We're also showing you all the possible bar charts. So this is the occurrence rate. So this, in the pandas world, you can think of this as value counts. So what is the value counts? So this is just the initial overview. But as you set your intent and attach that to the data frame, then we actually show more visualization that are based on, let's say, adding an additional attribute to what you've currently selected, or adding a filter so that you could look at different subpopulations. So Lux actually has this internal taxonomy that looks at different what we call action types, or different types of recommendations. And one of the things that we're trying to do is making that framework more extensible so that users can come in and add their own custom actions that are more relevant to their analysis. But the idea is that given a particular user intent, we can show a set of visualizations that might be relevant to that particular intent.
But when you say intent, you're basically saying a filter on which subpopulations for the data, right?
Yeah, so the intent is composed of the attributes that you're interested in, as well as the filters that you're interested in, so the values that you're interested in. And the two of them compose kind of where you're looking in the space of visualizations that can be constructed.
Right. Have you thought anything about, like, visualizing the outliers in the distributions?
We have looked at showing outliers in some of our earlier prototypes. It's not supported in the current prototype, but it is something that can be fairly easy in terms of adding it into the extensible actions that I just talked about, or the recommendation types. So you could imagine in the overview, there could be another tab that shows the possible outliers that are in your data set.
Great, thank you very much.
Thank you. So in the interest of time, I'm going to move on to the second part of the tutorial. And again, if you have any questions, feel free to leave them at the Slack channel, and then we'll have time for more questions at the end of the session. I'm going to share my screen again. Okay, so we'll move on to the hands-on portion of this tutorial. And so for the remainder of the session, we will be walking through the tutorial in this main room. All the instructions for the hands-on exercise can be found at this GitHub link. You can choose to work at your own pace for the tutorial, or just follow along this tutorial in our streaming session, which is going to happen in this main Zoom room. If you have any questions or need help at any point during the tutorial, feel free to let us know via the chat feature on Zoom, and one of the TAs will bring you out to the breakout room, where the TAs will be able to help you with your questions. And one of the things that you'll find at the top of the notebook is a line that activates logging capabilities to this notebook. And note that the logging is just for the purpose of RiseCamp. It basically collects anonymous usage statistics about how people are using Lux, so that we can improve these systems and these tutorials in the future. And so if you don't want your interaction traces in the notebooks to be collected, you can simply just delete this cell that has lux.logger equals to true, or simply not execute that cell. And the notebooks should still run as normal. So again, this is just something that we're doing for RiseCamp. It is not part of Lux, and it's just for us to kind of improve these tutorials for the future. So now I'm going to go over an overview of what each of the notebooks in the tutorial will cover. So the first notebook in the tutorial demonstrates how Lux features a flexible and expressive language that allows users to specify their analysis intent, such as what attributes and values that they're interested in. And users can specify their intent in a very sloppy manner, and Lux will automatically infer these underspecified details and determine appropriate visualization mappings. And this is based on a set of best practices and visualization encoding rules. The second part of the tutorial demonstrates how the same intent language can be used to create visualizations on demand. So Lux is built on this principle that users should always be able to visualize and explore anything that they specify without actually having to think about what that visualization should look like. So let's say that a user starts off by wanting to look at horsepower, and they specify that in lux, and then maybe they want to change, they want to add the attribute origin. And we can do that through lux, as well as maybe they now want to change the aggregation function from an average to a sum. And then maybe after seeing what they want to check out all the other visualizations with respect to horsepower. And so we see here that by providing an abstraction to let users explore data by specifying their intent, users no longer have to think at the level of code, but they can work directly with the concepts around the data. The third part of the tutorial looks at how users can click on one or more of these visualizations, export them, and programmatically access these visualizations further in their Jupyter notebooks. Visualizations are represented as viz objects in Lux, which can then be translated into code so that we can further edit these visualizations. So once you're done with these tutorials, we've provided a fourth optional notebooks for you to play around with other datasets and do your own investigation in Lux. And so now, now we are going to move on to the streaming session where I am going to talk through each of the notebooks and provide a brief overview. But again, if you want to work on these notebooks on your own, feel free to do that at your own pace. And again, all the installation instructions are on this GitHub repository. And one thing to note is that if you're having issues with installing and setting up Docker, you can also try out our Binder link. So there's a link to Binder. However, if you use Binder, note that since Binder is a service that we're not maintaining, none of your work will be saved unless you explicitly download these files. And I believe there's also a 30-minute limit on the notebooks. So this is, if you can't set up Docker on your laptop, feel free to go to this link and you should be able to open up a Jupyter notebook with all the tutorials that are listed. So now we'll move on to the walkthrough of these tutorials, and feel free to follow along or work at your own pace. So I'm going to switch to the notebook screen. So for this first notebook, what we'll be doing is we will be looking at how do you specify your analysis intent in Lux. And in particular, one of the things that that is important to note is that in Lux, the intent is always specified as a list of specification. So an intent is always a list of things that you might be interested in. Now, there might be only one thing in that list or multiple things. Intents can also be specified by these very convenient string shorthands. So in this case, what we're interested in is average cost. So we've loaded in the same data set, which is the college data set that we saw earlier. And then the intent is a property of the data frame. So we can set the df.intent as average cost in this case. So we're interested in average cost. So what we see here is, again, on the left-hand side, the current visualization is based on average cost. So we're showing the univariate distribution related to average cost. On the right-hand side, what we see is what happens when we add an additional attribute to average cost. So we can look at the various distributions that are based on that, as well as what happens when we add an additional filter. So this is essentially looking at subsets of the data for average cost. One of the things that we see is that on the left-hand side, seems like a lot of colleges have cost around 20K to attend. This is the most common sort of bucket. And when we look at different subsets of the data, one of the things that we see is that for private universities, this is more skewed towards the right. So private universities tend to be more expensive to attend, centering around 40K. Whereas for public universities, this is around 20K. So the distribution is more skewed towards the right, towards the left. So these are already some really interesting insights that we can gain by just looking at the recommendations. So let's say that in addition to average cost, we are now interested in the average cost and funding model. So we saw how like funding model can affect average cost, and so we're interested in the two attributes now. And note that again, the intent is specified as a list, and this is attached to the data frame. So when we enter that in, Lux applies these intent. And so on the left-hand side, we see funding model and average cost. And we again verify our hypotheses that private university cost much more than public universities to attend. On the right-hand side here, what we see is funding model actually being placed on the color channel. So the red actually shows the public universities and the blue shows the private universities. And it's really interesting how for a lot of these distribution, you could see this very clear separation because we have average cost on one of the axes. But also how it's interesting to see how it separates for different attributes that we're adding. For example, SAT average, and so on. And so let's say that in addition to average cost, we are interested in looking at different financial measures related to colleges, from maybe expenditure, median debt, and so on, and how that breaks down with respect to funding model. So the way that we specify a list of attributes that we are possibly interested in is through this OR relationship. So in Lux, we can specify a list of attributes that we're interested in, separated by this bar symbol. So if multiple clauses are specified, we essentially are creating combinations of these specified attributes. So in this case, what we are interested in is average cost or expenditure or median debt or median earnings. And all of these are measures related to financial measures of colleges. And we want to look at this with respect to funding model. And so what we can see here directly is that now we are creating these 4 visualizations with respect to the funding model. And again, we see that average cost, there's a huge separation between private and public. But actually, if you take a look at median debt and median earnings, and this is how much the students earn after they graduate from these colleges, there's actually not that much of a difference between private and public universities. So this is already something interesting that we can learn from these, by comparing the differences across these financial metrics for different funding models. Another thing that we can do, let's say that we have the same query. Another way we can specify this is through the list specification. So instead of having the bar, we can just specify this as a list. And Lux also operates on that and creates the same set of visualizations for us. So we've seen an example of how you can specify attributes that you're interested in, or one or more attributes that you're interested in with Lux. And now we wanted to take a look at how do we specify that values or subpopulations of data that we might be interested in Lux. So let's say that we are again looking at colleges and we are only interested in the colleges located in New England. And note that Lux supports this kind of sloppy shorthand for us to specify filters. So we first specify the filter attribute and the equality. So it could be a larger or smaller or equals. In this case, we are interested in colleges where region equals to New England. We attach that as an intent again. And what we can see is that all of the recommendations of the overview that we're seeing is based on this region equals New England. So all of them have this filter being applied. So now we'll actually move on to the first exercise where you'll get a chance to play around with Lux. And so you can specify multiple values of interest using the bar notation that we saw earlier. And in this case, we want to write a query that that specifies basically how do you compare, that specifies comparing the median debt of students from colleges in New England, Southeast, and Far West. So again, we are writing the code to specify this intent. So we're going to take a couple minutes here for you to work on this exercise, and then we'll go through the solution together. And note that we will be launching a Zoom poll. So as soon as you have gotten a chance to try this out on Lux and are able to complete it, please let us know through the Zoom poll.
Hi, Doris.
Hi.
This is Yishao again from FutureWay. Did you update your Docker image last night? I think I downloaded the Docker last night, and I found that my notebook is not the same to yours. So I didn't see this exercise as one in the end of my notebook.
It should be there. Are you in the exercise folder? Does your directly structure kind of look like this?
Oh, I see. Yeah, I'm looking at the tutorial. So I should go to the, yeah.
Yes, yeah, you should go to the exercise. Perfect. So we are going to walk through the solution of the exercise together. And so what we want to do here is we are interested in the intent that we are interested in is median debt. And we are also interested in students that are from New England, Southeast, and Far West. So we learned that earlier we can specify an OR relation with a bar notation. And so we will try that here. New England, Southeast, and Far West. So this is the intent that we're interested in. And note that we have to attach that to a data frame. So this would be our data frame intent. And then finally, we want to print out our data frame and take a look at the results. So here, as expected, we've created these 3 visualization for different regions and looking at median depth and how that changes across the regions. So hopefully this notebook gives you a taste of what specifying intent looks like in Lux. And we'll move on to the second set of tutorials where we will be introducing how the same intent language can be applied to creating visualizations on demand based on what you're interested in. So in this tutorial, what we'll be looking at is an Olympics data set. The Olympics data set is essentially a data set with information about Olympic athletes. And so in Lux, we have this construct called the viz object. And the viz object represents individual visualizations that are displayed in Lux. They can either be programmatically generated, like we've seen earlier with the data frame and the recommendations, or they can be defined explicitly by the user. And to generate a visualization object, users need to specify 2 things. One is the intent that is associated with that visualization, and the second is the source data frame. So what data are you using to generate that visualization? And here, let's say that for the Olympics data set, we are interested in visualizing weight as an attribute. So the intent that we specify is the weight, and we also attach the data frame to that. So here we can see we're creating a viz object with the intent of weight, and the data frame is df. And when we plot this, this variable viz, which has the viz object, the visualization shows up right away. So this is a very quick and dirty way for you to start playing around with your data if you know what you are looking for. And so we saw earlier that the viz object is composed of 2 things. It's composed of the data, which is the data frame, and it's composed of the intent itself. And so in order to iterate on that visualization, you can either change the data or you could change the intent. So let's say that we are interested in only female athletes. So we're only interested in the data points that corresponds to female athletes. We can see here that we can filter to that particular subset of the data and use that to refresh the source of that visualization. So, so what this is actually doing is it populates this new data frame into the same visualization specification or the intent. So we can already see that for this data frame, for female athletes, we have weight that is skewed towards the left compared to the overall. So female athletes tend to be lighter than athletes overall. Likewise, we can modify the intent. So that is the other axis that we can modify. And let's say that we want to make the bin size of this visualization more fine-grained. We can essentially specify that the bin size of weight should be 50 instead of this is the default 10. So we change the intent and we can see that the visualization gets updated. So this is modifying the intent is a quick way that you can start customizing your visualizations based on what you're interested in. So we move on to our second exercise. And for this exercise, we want to plot a visualization that shows the number of athletes for different regions across Winter and Summer Olympics. So again, we want to write the code to create the viz object that corresponds to this visualization. And we'll again take a couple minutes to go over this so that you can work on this before we go over the solutions. Okay, so it looks like folks are able to finish this exercise, so I'll really quickly go through the solution for this exercise. So typically when I am plotting a visualization, what I generally like to do is I would print out this data frame, and I just want to look at kind of what is the columns that are in my data set. And in particular, we know that we care a lot about athletes from different regions. So we probably care a lot about this attribute athlete regions. And another thing that we care about is this winter versus summer. So it looks like seasons, the seasons attribute is able to capture this. And so what we care about is seasons, season, or actually season and athlete region. And again, we want to make this the intent, and we want to feed this into the viz object and also feeding in the data frame. So we can see here that Lux automatically generates this visualization for us that corresponds to what we want. We also see that there are more athletes in Europe than many of the other continents. And also in general, there are more Summer Olympic athletes than compared to Winter Olympic athletes, shown in blue and orange. So this is a very quick way of specifying the visualizations through the viz object. And so let's say that in addition to specifying a particular visualization that we're interested in, let's say that we are now interested in specifying multiple or collections of visualizations. Lux has this abstraction called the viz list object, and the viz list object allows us to specify groups or collections of visualizations that we're interested in. So let's say that we are interested in looking at weight, the weight of athletes with respect to all the other attributes. So we can use this viz list construct to create an intent where we are interested in weight and also this question mark. This question mark is a wildcard symbol, which basically says, show me anything. So in this case, it would be anything with respect to weight. So when we plot this viz list, what we see is a list of visualizations that with respect to weight. So this is a useful way to kind of get an overview of what are all the things that are related to this attribute. So now we'll move on to the second exercise. And here we want to plot a list of visualizations that shows how the physical characteristics of athletes, such as age, weight, and height, changes over time. So we want to create a viz list that that generates this. And again, we'll take a couple more minutes to work on this exercise, and we can look at the poll. We'll use the poll as an indication of what our progress is. Okay, so it looks like some of you were able to work on this exercise, and so we will take a look at again how we can plot a list of visualizations based on the physical characteristics of the athletes and how that changes over time. So one of the first things that we care about is sort of physical characteristics. So age, weight, and height. And note that in the earlier exercise, we did this with the bar notation. Here we're doing it as a list, just to kind of switch things up a little bit. And these are the physical characteristics that we care about. And we want to also create a viz list, which is not just these physical characteristics, but also how that changes with time. And time is actually captured by the year attribute. So this is our intent. And then we want to attach a data frame to this. So then once we attach the data frame to this, then we see how age, weight, and height change over time. And one really interesting thing to note is that a visualization list can also be specified by through a list of viz objects. So you can actually manually create these viz objects and then put them into a viz list to display them. So instead of using kind of this combination notation that we have, we can actually explicitly create a viz list. So I'm just going to walk through this example. This is kind of a bonus exercise that is going to achieve the same thing as what we've done here. So what we can do here is we can call this a viz v list. And this is just a regular Python list. And we can iterate over the attributes that we're interested in. We already created this variable called physical characteristics, which has age, weight, and height earlier. And so what we're going to do is we are going to do a for loop across these physical characteristics. And for every for loop, we are going to create a viz object. And inside that viz object, what we care about is year with respect to this attribute. And again, we have to put the data frame in here. Actually, yeah. So we have to specify how the viz list or the v list essentially adds these visualization into the list. And so here we can just see this is just a list of viz objects, but this is not our viz list yet. This is just a list of viz object. We can place this into a viz list and then finally attach data to this. So we can attach data at this very last step. So then now we can see that we can use kind of a programmatic way to create visualizations and put it into a list in a viz list. So now we're going to move on to the third notebook. And in this third notebook, what we'll be looking at is what happens when you find something interesting in Lux and you want to export it or share it to your collaborators, or even just delve into it a little bit further. So here we will be looking at the HPI dataset. This is the Happy Planet Index data. This is a dataset that is related to the well-being metrics of different countries around the world. And so let's say that we are printing out the data frame and getting an overview of our data. And we are already seeing some really interesting patterns and trends in our data. For example, there are trends that are positively correlated and kind of this weird shape. So we selected a couple that we kind of found to be interesting, and we can actually export these visualizations into the Python variable. And in Lux, the exported visualizations can be accessed through the data frame property df.exported. So when we print this out, these three are the ones that we selected. They are now printed out in the df.exported. Now, another thing that we kind of noticed from these overview visualizations is that there seems to be something that's kind of interesting here. So there is this visualization that is showing GDP per capita with respect to footprint. We are seeing that for most countries, the higher the GDP, kind of the higher the footprint. But there's this one particular outlier that is just way off in the chart. And so we're kind of interested in this. So we're going to click on this visualization and we're going to export this single visualization. And visualizations are always exported as a viz list. So we're just going to index to the first one. So this is the only one that is in our exported. We're going to save that into a variable called GDP_footprint. And now this is a viz object, as we saw in the earlier tutorials. This is a viz object that we can now programmatically work with. One of the things that we could do is we can set the visualization intent of the data frame based on this visualization. So let's say that we want to find other visualizations that are related to GDP per footprint, or just taking a look at this visualization a little bit further. We can set df.intent as GDP per footprint. And on the left-hand side here, we could see that the current visualization is the specified intent, which is GDP per capita and footprint. And on the right-hand side, we can see other visualizations that are related to this. Another thing that we can do with a viz object is we can export the visualization into code. So Lux is built on top of a Python library called Altair. And Altair is a declarative visualization library for doing exploration and just plotting visualizations. So we can actually synthesize the Altair code based on the viz object. So we can actually print this out by this command called to_Altair. And this is really nice because then we can start to copy and paste this visualization, the code related to this visualization into a different cell and just print it out. So it's the same visualization, but now it is an Altair chart. And this makes it very easy, given that we have the visualization code, for us to do things like just make the width larger, or maybe we can make the title something really huge, maybe 20. So we could see how we can now start to fine tune the aesthetics and the styling of the visualization using this, this code that we have. Another thing that we could do is exporting this as a Vega-like specification. And this is just a JSON specification for that visualization that you can then embed into your HTML web page or dashboards. And so this is the final tutorial notebook that we're going through. In the fourth exercise, what we have is we have a data playground. And inside this data playground, what you'll see is there is a lot of different sort of data sets for you to play with. So we can spend sort of the remainder of this tutorial kind of playing around with these data sets. I have some starter tasks or things that you can try out based on what we've covered today. What you can do is just copy and paste one of these data sets and then start exploring them. So we will check back in again in about 5 to 10 minutes. I'll give you guys some time to play around with this data playground. And also we'll be in the main session. So this is also a good time for Q&As and any questions that you have based on what we've talked about today.
Doris, there are a couple of questions in Slack. I don't know if you want to answer them right now.
Okay, let me take a look at this right now. So there's a question by Ricky about the rank order of visualizations and how that relates to the possible the user intents that the user has specified. And in particular, the question has to do with whether we track any user intent in terms of inferring the rank order. Right now, most of the metrics that we have is based on interestingness scoring. So what this is it's some sort of statistics that indicates how interesting a visualization would be. For example, a correlation or something that is highly skewed or something that is very uneven. All of those are interestingness metrics that we use. And then on the other hand, we also have the user intent that people have specified, and that actually is being used to drive the decision around what types of recommendations are we showing. So if we have, let's say, if we've selected a single attribute that is quantitative, then we are showing a histogram, and so things that we can do is adding an additional thing on top of that or adding a filter on top of that. So this is the enhance and filter tabs that we saw. And currently there isn't a way of using the user intent to drive the interestingness scoring, but that is certainly an interesting idea that we could explore further. Let me know if this doesn't answer your question, and feel free to just let me know. Otherwise, I'll be going through the list of questions that we have on Slack. I think another question that we have is by Xiaolin about whether Lux calls the Pandas API to compute statistics or use some other libraries. So Lux is designed to be kind of a wrapper around Pandas, and in particular, it actually the way that it is a wrapper around the Pandas API, it actually allows us to inherit all the function calls and API functionalities that Pandas have. And we do call Pandas internally to compute statistics, and we also leverage NumPy and SciPy for some of the statistical functionalities. And yeah, so that's kind of an architecture of what Lux is doing. Let's see. There's another question by Ricky about whether the visualizations can be used for prediction models, for test data evaluation, like AUC, plotting AUCs, partial dependencies, and things like that. As I mentioned earlier, one of the things that we're really excited about is trying to make Lux as extensible as possible, and just creating a framework that allows users to tie in their analytics with a very powerful visual display, and being able to let users tune and play around with that at a very high level. And so I think all of the ideas that you've listed, the AUC and the partial dependency plots, those are very exciting ideas, and I think they make sense for test data evaluation and for machine learning use cases. So that's definitely something that we can incorporate in or have this as a user-defined function in Lux. We're definitely interested in working with you folks to kind of incorporate that into Lux and trying to make Lux support all of these use cases. So we have about 5 minutes left, so I'm going to go back to just this conclusion slide and so that we can wrap up our session today. Let me share my screen. It's the wrong screen. Okay. So we hope that the presentation today gives a taste of how Lux can help enhance the data exploration experience in computational notebooks more expressively and through a visual manner. And one of the things that we want to emphasize is that Lux is a low barrier way for working with visualizations in a computational notebooks that facilitates exploration. And Lux is still a very early stage project, so we're actively working with users on how to make this tool more useful. So we're definitely interested in working with all of you. Please send me a message if you're interested in Lux, and we can see how to make this more useful for your use case. One final thing is that we have a survey for providing feedback. And so please fill out our really quick survey, provide feedback on how to shape the direction of this project. And thank you again for joining the session today. I know it's been a long day with RiseCamp, and this is the very last session of RiseCamp. And I'm happy to take any questions with the time remaining in the session, or on Slack or email offline. So thank you again for joining.
Thank you, Doris.
Thank you.